Hello my friends of Qatari Lab, my name is Saul Montoya. Welcome to this tutorial. This tutorial is the interactive pumping test interpretation with MODFLOW6 and FlowPy. What is this tutorial about? This tutorial about is how can we evaluate the drawndows due to pumping on an interactive way. What does it mean? That here we have, for example, a cross section where there is the pump here. This is the distribution of the water heads, and this is a slider where we can see and then we can interact with the different water tables at different time steps. For example, this is in days. This is a first day of pumping, second day, third day. If you see here, these are dry cells. Yeah, those are dry cells that have been, because actually this is this has 40, this one has 20, no, it has 30 layers. So this is the first layer is dry on this part. Okay, and then here we see which is the drawndown at the well, and this is the development of the drawndowns. Here there are two boundary conditions. And okay, so this tutorial will be about how can we create a model, yeah, and how can we do this interactive interpretation. Okay, the files for this model are on the description of the video. Yeah, so actually you can have everything to represent this model. Okay, so on this video, this is a walkthrough through the exercise. It's very interesting. This exercise is very interesting, and I hope that I can explain you in a better and the most clear way, because I am really interested that you can follow this tutorial and then you can understand. This is the objective of the tutorial, that you can understand how how is the aquifer response due to pumping. Yeah. Okay, so I will start a clear output just to start. Okay, great. So we start. Okay, first we import FlowPy, MATPLOTLib, NumPy, and pandas. Actually, pandas is not, well, I have imported pandas, but pandas is not required for this tutorial. Then we create the simulation name. Yep. And why simulation and why model? Because this is the model name and this is simulation name, because actually in MODFLOW6 you can exchange from models. I mean, one simulation can run different models and then you can change the result from one model to the other model. Okay, but in this tutorial we are not going to change anything, so it's just one simulation that runs one model. Okay, and here is where you define the executable. I work in Windows, but actually if you compile this on Windows, on Mac or Ubuntu or Linux, is according to, oops, sorry, you will receive this folder, and on the folder here you have the scripts. That is the script that runs this. The simulation is actually where the simulation, the MODFLOW files will be stored, and the executable is where the executable, the MODFLOW6 executable is stored. Okay, we define a simulation, we define a MODFLOW name, we associate the model name with the simulation. Okay, and this is the GWF model, that is the one that implements the Newton-Raphson formulation, that is similar as the MODFLOW NWT. Okay, but this is on MODFLOW6. Okay, then we create a temporal and spatial discretization. We have two stress periods of 10 days Yep. We have 100 cells. I mean, our model is 101 times 101, also 101 columns, 101 rows, and the cell size is of 1 meter. Yep. And we have here we have we create as since you have to insert this on the discretization del R and del C, you as a list, we create with this we create a list, and then we create as well a list for the bottoms. Why? Because we define the top, and since we have 30 layers, like we have the bottom of the 30 layers, so we have to insert as well. Yeah, so I will run this. Oops. I will run this, I will run this, I will run this, I will run this, and then I will run this as well. Okay, and these are the bottom for the 30 cells. Yeah, and this is where we define the K, the hydraulic conductivity. Yeah, and on the well cell, all the well is defined as really high K of 1 meter per second. Why? Because actually on the well cell there is no aquifer, so if you pump water, actually will be connected from the top to the bottom. I mean, if you pump 5 liters, actually it will have an impact on an immediate impact on the top of the water table on the well. Okay, on the level on the well level. Okay, so this something that is really helpful and very powerful is that you can define in FlowPy the K as a constant value or as a NumPy value, as a NumPy array, and in this NumPy array actually I can define, for example, that till layer 20, so till layer 20 on the cell of the model, it will have 1 of hydraulic conductivity, and this is as NumPy. Okay, and for you that maybe you are not familiar with Python, and if you are familiar with NumPy, the slicing procedures in NumPy are really helpful if you want to define hydraulic conductivities, if you want to define topographies and so on, because or like even boundary conditions. Yeah, I strongly recommend that you do some tutorials on NumPy and the slicing on NumPy. It's slicing of arrays. Okay, so we run the hydraulic conductivity. The initial conditions are the starting head is 99, because remember that the model goes from 100 to 40 and the starting head is at 1 meter below surface. Okay, and then here we define the specific yield and the specific storage. Okay, so we run this as well, and then here we define 2 boundary conditions. The first boundary condition is surrounding constant head, and why we use surrounding constant head in our model, because we want to create numerical stability to our model. Otherwise, like the computer, I mean, based on my experience, the computer will have lots of freedom to define the solution, but you know that the water level at the extreme of the model won't change so much, so that's why you create this boundary condition. Okay, and this is the well package as well. Yeah, here this is the well, and in MODFLOW, wells are, I mean, if you define a well, the well is located in one cell, but sometimes this could be very, I mean, but you know that not all the well, that you are not pumping just from one part of the well, but you are pumping from the entire well. That's why we have divided the well the pumping rate in between 5 cells. Okay, so that we know that will be saturated along the pumping test, and that is why here we see this is the pumping rate by divided by 5, because actually we have set the pumping rate in 5 wells for the first stress period and for second stress period, and here we insert this well data into the well package. Here one. Okay, and then we define some outputs. We define some output control. I mean, what do we need on the listing file, and also in the as the binary files and so on. We run. Oops, sorry. We run this as well. Yep. Okay, and then it's running. It's kind of slow. Yeah, and why is slow? Because you have 101 times 101 times 40, so you actually your model has 400,000. Yeah, it's close to 500,000 elements just to interpret the hydraulic response, the response of the aquifer to pumping. Okay, and maybe, and this is maybe could be a topic of another tutorial, because I have found that if you don't put an adequate number of cells, you will get another response on the well, and then if you get another response of the well, you cannot fit to the observed wells if you have done a pumping test. Okay, so if you want to save layers, yeah, maybe you won't create the adequate aquifer dynamics to represent the observed, to match in between the calculated and the observed. Yeah, this is in my experience, it's not common that you have 40 cells. It's more common that you have 3 or 4 cells, maybe 10 cells, but nobody tells you, okay, do your model with 100 layers. Yep, no, this is not common. Yeah, and maybe we have to, in the future, we have to shift to models that can be run in more cells, in higher amount of cells. I know that MODFLOW is in MODFLOW do not care much about if you are working with 100, 200, because Fortran because MODFLOW is written in Fortran, and Fortran is very high, is very good for high computation. However, it runs on just one cell, and then if you want to run this, or like most more complex models, maybe you want to run it with on parallelized computing. Yeah, and then you have to do some arrangement in MODFLOW, maybe in Linux, to parallelize your Fortran code. Okay, so this is for the first, and then it's running the second. Okay, I have done a function for water table. Yeah, and then I have done another function to plot the cross section, and then what else I have done, I will delete this. I have done this IP widget, that is the interaction. This one introduces a slider that where we can we can change from days. We can change from days, or mostly from time steps. Okay, so okay, let's wait. Okay, so far we have something new in Hatari Labs. For you that follow our tutorials, we are very happy to have you on our blog, following our blog. But something new is that we have, well, you can also hire us. but we have had email. So actually, if you have an idea of a topic that could be worth to create a tutorial, you can contact us by email. If you have like a specific inquiry about something, and then if we can provide you a hint, okay, you can write to our email. Okay, actually we do not do homework, and then we do not give a specific support. Yep. So if you want to discuss about if MODFLOW6 is better than something like that, if it's a general question, or then if you want to know more about another software, yeah, you can write to us, you can write us. But if you write me and say, oh, my model is not running, and I will tell you maybe I cannot help you. Okay, so Saul Montoya at hatarilabs.com is our email, where you can contact us, and then you can we can have a further discussion on modeling. That is something that motivates us a lot. Okay, I will run the output representation wells. Okay, and here you see the well. This is the distribution of water heads, and here I use the keyboard to interact. Okay, or maybe with, and then you can see how this well, and then if you see as well how the water heads are developing in the on not only on the water table, but as well with depth. Okay, so far, thank you for following us, thank you for following this interesting and very complex topic. Hope to see you in coming tutorials, and if you like this video, please subscribe to our YouTube channel and give it a like and share it through your social networks. Once again, my name is Saul Montoya. Hope to see you in coming tutorials, and have a great day. Bye.